Good morning, ladies and gentlemen. Today we're going to continue with electric forces and fields, and today we're going to focus on section 2, which is electric force. Okay. It starts us off with a prompt discussing the differences between electric force and gravitational force. And it's something I think it's important, so I'm going to go through it. Electric forces and gravitational forces are both field forces. If you remember, a field force is a force that does not require contact in order to be felt. Okay. You do not need to be touching anything in order to feel gravity. Okay, so gravity is a field force. Same thing with electric forces. It says, imagine we have two charged particles. Okay, two electrons attract each other due to gravity. Okay, so gravity is pulling electrons together. But the electric force is also pushing them apart. The question is asking which force is greater and how do we know this? Well, yesterday, when we were doing the static charges with the hair in the balloon, you saw that when I brought two negative balloons together, they pushed each other away. So, which force do you think is stronger? The gravity that pulls them together or the electric force? In this case, the electric force, because they're pushing each other away. So, the electric force is winning. Okay. When it comes to gravity and comparing force strength, you need to take into account relative size. Gravity only becomes relevant when you have very large things like planets. Okay. So I told you that we all are pulling things towards us. We all have gravity. We're all mini black holes, but our force or our gravitational pull is not that strong because we're not large. Okay. So which force is greater? It depends on the scale. We're talking about electrons and protons and things that small. When you're talking that small, gravity basically becomes irrelevant. Okay, it exists, but it's very, very weak. So electric force is by far the stronger one of the two. Okay. So today we're going to learn this thing called Coulomb's law. Okay, remember yesterday, Coulomb is the unit of charge. Okay. So Coulomb's law allows us to calculate just like the exact force between two charged particles. So if I was to bring two electrons next to each other, the amount of force they would be pushing each other away with, we can calculate that with this equation. Okay. The equation is force is equal to Coulomb's constant. This is just a number, okay? So this is you don't require any memorization, just like that 9.81 gravity number, this is just another number, okay? So Coulomb's constant times the charges of each particle, and then you divide that by how far apart they are, okay? So you would say in this case that the force has a direct relationship with both charges, meaning that as the charge increases, the force increases. And it has an inverse relationship with distance, meaning as distance goes up, the force gets smaller. And it makes sense. Once they push each other apart, they're no longer pushing each other, so that force goes down. Okay. So this is the Kc value. Again, you never have to memorize this. Okay, I'm never going to ask you to memorize constants. Okay. This is just a value, and this is the value. So this is what you're going to be using for Kc, okay? Okay. And I want to save the example problems for the worksheet. Okay. Aside from the forces, you can have multiple forces. So they call this thing the superposition principle. Again, so everything I just skipped, these are just examples using the equation. Okay, this is the force equation, then they have some examples. We're going to go through some examples in the worksheet, so I'm going to forego this for now. But another thing, there's this thing called the superposition principle. And what it's saying is that if you have more than two charges, so you 3, 4, 5 charges of particles in the same space, they're all technically interacting with one another. Just like how technically everything has gravity and they're pulling and pushing on each other, same thing here. Okay, so in this case, what they have here is they have 3 particles. You have one electron and you have two protons. Okay, one negative charge, two positive charges. In this case, if we're looking at the negatively charged particle, the negatively charged particle is going to be feeling a force coming from the other two particles. Opposites attract. Opposites attract. So this is going to feel a pull this way, and this is going to feel a pull this way. It's going to be pulled towards the positive charges. If we look at this charge, this is going to feel a pull towards the negative electron, because again, opposites attract, but it's going to feel a push. It's going to feel a push from this other proton over here, so it's going to feel a force this way. That's in line with the dotted dash that you see here. And same thing with this one, and they already have it drawn. You can see that this proton is going to feel a pull towards the electron and a push from the other positive particle down here, okay? And this is what the superposition principle is saying, okay? It says the net force on a charged particle is the sum of all the forces due to the other charged particles. That's all this is saying, okay? So it's this superposition principle is the same thing as the force equation, okay? But you're just calculating multiple forces. That's all that is. And then more practice problems, okay? And then they go through here, okay? Electric force, similar to gravity, is a field force, okay? Both forces both forces are related to distance in the same manner. What are they referring to? The closer you are to Earth, the more you feel its gravity, okay? That's why as you go out to outer space and you float away, you feel that gravity less and less. Same thing with electric force. If you bring two charged particles together, the closer they are, the more that electric force increases, okay? But the difference between electric force and gravity is that in electric force, there are two types of force. You have positive and you have a negative. In gravity, there is no positive, negative, there's just gravity. In electric charge, you have positive and you have negative forces, okay? And electric forces can they can push away and they can attract. Gravity only attracts. Gravity is always pulling you towards something, okay? You are attracted to it. Electric forces can repel and attract, okay? And they say electric forces are far stronger than gravitational. I guess if you're comparing it pound for pound, maybe, but as I stated previously, it depends on the scale. If we're talking about small stuff, and by small, I mean not planets, then electric forces are stronger. If not, gravity is stronger. Okay. And this is just an apparatus. You can look up a YouTube video on it too. I couldn't find anything that I liked. So I didn't want to endorse anything. But if you find something on it that you find interesting, by all means, go for it. But this is one way to measure Coulombic force. Okay, it's a very delicate apparatus. You have some things floating and you have charged particles, and the only thing that causes it to move is the electric force, and that's one way to measure it. Okay, and that's the end of this section. Okay, hopefully that wasn't too bad. How long? That was only 8-9 minutes. Okay, that's not too bad.